Hello, Mrs. Kendrose. Mrs. Kendrose class, you are going to get a lesson from Mr. Higgs today by a video. So we're going to be doing ellipse today, and this is what an ellipse looks like. And you'll notice that there are two dotted lines on there. Those are called asymptotes. And as you guys know from graphing some other equations like tangent or cotangent, asymptotes are lines that the graph will not cross. So asymptotes are very similar to the ellipses. You're going to have to find some vertices and create, not in this case major or minor axes, but you're going to have to determine the distance between the two vertices. We'll be doing some of that today, and we'll talk about how to come up with that vertice and the equations dealt with those. So there's two different types of hyperbolas. There's a north and a south which is just like the example here. This would be we consider a north and a south because it opens up and down. And then the other kind is an east and a west. And if you can observe the two equations, north and south are going to be in the form of y squared minus x squared. And an east and a west will be in the form of x squared minus y squared. Now those both have the vertices being at 0, 1, and 0, negative 1. We're going to deal with some where the vertices move a little bit. So here's what an east-west looks like. So again, we're looking at the vertices, and the vertices for an east-west one here, 1, 0, negative 1, 0. And if you'll notice, that's going to have something to do with the number that will be underneath the x and the y in the equation. And when I show you the general equation, you'll see where that comes from in just a moment. Here is the general equations that you'll deal with when the vertices are not going to be 0, 1, 0, negative 1 for a north-south, or 1, 0, and negative 1, 0 for an east-west. So we're looking for numbers underneath y squared and x squared to help us identify the points where the vertices will occur. So here is the general formula, and the slope of the asymptotes, those dotted lines, will be found by doing plus and minus a over b. So whatever number is being squared underneath the y here is going to be the a, and whatever number is being squared under the x is going to be the b, and we identify the slope of those two lines by just writing them as a fraction, and then plus or minus because they're going in both directions. And then notice here that the vertices are going to be identified as 0 plus a and 0 negative a. So those are the two vertices that I was referring to before that were just 0, 1, 0, negative 1. But the minute we start dividing by numbers, we're going to change that. So that's for north-south. We're also going to refer to the foci, and the foci in this case, very similar to an ellipse, but the foci actually is not on the hyperbola. It's actually going to be two reference points inside the hyperbola. And we'll talk a little bit more about that, or maybe Mrs. Kendrow will when she gets some examples for you. So they're found by using a formula very similar to an ellipse. I think you guys had something very similar to this. C can be found by doing c squared equals a squared plus b squared, which should look familiar to you. That's a form of Pythagoras' theorem. An east-west opening is just switch the x squared and y squared. Hyperbola, I hope I didn't say ellipse, hyperbola. And here, notice a squared here on the north-south is underneath y squared, whereas on the east-west, it's under the x squared. So a and b do not switch with x and y. A will always be the first number, b will always be the second number. It does not change a and b, just the x and the y switch, which changes the direction that the hyperbola will open. The same thing holds true for finding the slope, except for now A and B are flipped. So the slope of the asymptotes will be flipped for the problem. And the vertices now will be x values instead of y values. And the same thing is true for the foci. You still find the foci the same way, but in this case, we're referring to y values for the foci over here and x values for the vertices. So let's look at an example and see if you can determine what the vertices and the slope of the asymptotes are and what the foci are, and see if we can maybe sketch a graph. First, let's just determine if this is going to be a north-south or an east-west. So there's the two forms, north-south, east-west. And if we look at this example, it looks like this is going to be a north-south. So we can determine this is a north-south, so it's going to be opening up and down just based on that form that we have there. Well, in this problem, we can identify A to be 5 and B to be 2. So now we can find our C, because C will end up being 25 plus 4 in this case, square rooted. So it'll be the square root, if I can write a 2, of 29. So there's, so the foci in this case will end up being, having a little trouble with the pen today, plus or minus square root of 29, 0. And that's just based on the formula up there. The slope of the asymptote will be negative plus or minus A over B, so 5 halves, plus or minus 5 halves. And then we can identify the vertices to be 0, and in this case, it'll be the y values plus or minus 5. So that's how you identify the parts to it. Now we can kind of sketch a graph based on where this information is. So we can look at 0 plus or minus 5. So we can go 1, 2, 3, 4, 5. There's a vertice. 1, 2, 3, 4, 5. There's a vertice. That's basically where the ellipses will pass through. The foci, which we identified to be the square root of 29, is going to be somewhere up in here. Somewhere up in here, the square root of 29. Actually, that's plus or minus. And then somewhere down in here. Those are only used for sketching it when you use a different method to sketch it. We're going to use the slope of the asymptotes to help us sketch what that looks like. So if we sketch the asymptote to go through 0, 0, so we start here, we're actually going to go up 5 and over 2. We're just going to draw a dotted line there to represent that slope. And then the other one being down 5 and over 2. So we go down 5 and over 2. And again, we just want to draw a dotted line there to represent where those won't cross. So this is a north-south. So then what we're looking for is for our ellipse to basically come across on those lines through our vertice. It look like that. And then this one will come and sketch like that. So that's what a north-south one looks like. And the east-west one will look very similar to that. It's just going to be going the other way. So that's your example and the notes for today. You can have the sub rewind this a little bit, or you can go to your book and write down the formulas. I believe they're in there as well. I hope this helps. I am just down the hall. If you need a quick question, you're welcome to send somebody over to ask. Here are some problems that you can work on. I just kind of pulled these out. I hope these are some that will be in reference to what Mrs. Kendall will be working with. So on page 555, you can do 1 through 13 odds, and then you can do 15 and 19. And I believe that's the practice problems, not the class exercises. Have a good day.